Hey, what's up? It's Shahkar here, and we're going to go over some awesome things like factoring, some special products of equations that sometimes can be kind of crazy. So we're going to go ahead and try to do some of those. All right, so let's say we had one that was super fun. I know, I'm excited about some super fun time. We had like x squared, except that instead of squared, let's make it even more fun, like cubed. Oh. So if I have x cubed plus 6x, and then I say minus 5x squared minus 30. Okay? So let's say if I rolled with these guys. All right? And the thing is I want to, first of all, I'm going to put this in what's called ranked order. So I'm going to start with the guy with the highest degree. Now, the degree has to do with these bad boys here. All right? It's almost like exponents, but it's not exactly. Okay? Because in this case, this guy had a degree of 3, this one has a degree of 1, this one has a degree of 2, and actually our constants have a degree of 0. But you can't think of it like an exponent of 0, because anything to the 0 power is 1. That's correct. So you can't think of it like exponents exactly. But since we talked about degree, 3, 2, 1, 0, that's the order we're going to put them in. So now I have x cubed plus, minus 5x squared, plus 6x, and then we have minus 30, okay? So with those, I'm going to go ahead and I'm going to work this through, okay? Now, right now, factoring this is a little tough, but what if I broke this into two separate sections? Like, let's say we had x cubed minus 5x squared, which is what this is, and let's say I did a separate one of 6x minus 30. Now, it's still the same. And let's say I'm still going to go ahead and add these together, because that is what's happening, right? But let's say I enclosed these as separate items, all right? And let's say I took them piece by piece. Now, I'm going to extract something common out of both of these. Now, what's common out of x cubed and negative 5x squared? And the x squared is common, okay? So I'd be extracting that out, and I'd be left with x squared goes on the outside, and what's left on the inside is x and negative 5. And if you're not really sure why I did that, remember that x squared times x is x cubed, and negative 5 times x squared is negative 5x squared. Okay? But now let's say I pull this out over here. Okay? And so what's common between 6x and negative 30? I can pull a 6 out of each of those. So if I pull a 6 out, what I have left inside is x minus 5. Are we good for that? Okay, so what I see now is that x squared times x minus 5 plus 6 times x minus 5. Oh, I'm noticing a pattern here. All right, that these guys here, it's kind of matching up. And what I can actually do now is I can write it as x squared, which is going to come from here, plus 6. If it can multiply times x minus 5. And I forgot to put the square. I'm really sorry about that. Okay? So if you're looking at this like, where did he even get this stuff? Well, if we bring him from over here, and we bring him from over here, the truth is that x squared is multiplying times x minus 5, right? Which if we FOILed, okay, some of you may have learned that pattern, I'm still going to be multiplying x squared times x minus 5 if I was trying to get back to the original. All right? And then if I had 6 times x minus 5, that would still be happening if I FOILed. Okay? And so this would be the factored version of this, okay? Where I have extracted that out. And I've just factored. I haven't found the roots, but this is my factored form for that. Okay? Let's go ahead and let's do another one, just to make sure that we're comfortable with this. Okay? So, and if I wanted to, I can go ahead and multiply these back out, which would give me this guy back up here. And be like, what? Okay? But we're not doing that, because then you're just multiplying to divide, to multiply, to divide, to multiply. Moving forward. Now, I'm looking at this bad boy, and I'm all like, what up? Let's do this! Okay? So I want to go ahead and factor this out. Now, first of all, is it in order? And let's check their degree. 3, 2, 1, 0. Because remember, this is a constant, and so the degree is 0 when it comes to polynomials. Boosh! So this is in order, and I'm really excited about that. So let's go ahead and let's separate these out, okay? And so let's go ahead and separate this section over here, all right? And then I'd be subtracting this section over here is the idea. Or actually, I could also do it. Let's do it like that. All right. Now I know that just looks donkey crazy, so I apologize for the donkey craziness. But here we go. If I write it now, I have 2x cubed plus 3x squared, and we could say plus negative 8x minus 12. This is the monomial of negative 8x, and this is a constant of negative 12. Okay? Hopefully that's clear. Sorry if I made something confusing there in a second ago. All right, here we go. I'm going to go ahead and see what's common between these bad boys. 2 and 3, nothing common. X cubed, x squared is common. Let's bring it. Let's bring it. And so on the outside, I've got x squared, and inside I've got 2 plus 3. And what did I leave out? I left out an x, because that's got to multiply to make 2x cubed. And this is a squared on the outside. Hopefully that's cool. And now I'm going to say, what do I extract here? And from this one, I can go ahead and extract, I could extract a 4. But let's extract a negative 4, because these coefficients here are making me feel not so hot. All right? So I'm going to extract a negative 4. So on the outside, I'm pulling a negative 4. Boosh! All right? And so then what's left inside? Left inside is 2x. And let's see, negative 12 divided by negative 4 is going to be a positive 3. Oh, my stars. I go ahead and I see I've got a 2x plus 3 and a 2x plus 3. What? Oh, let's do this! Okay, so from there, I can go ahead and say I've got x squared, which is from here, minus 4, which is from right here. Boosh! And that's going to be multiplying times 2x plus 3. What now? Now look at this. Oh my goodness. I've got an x squared minus 4. Now if you think back to the days which you had, let's say, your sum and difference pattern, okay? I mean, the sum and difference pattern. Your difference of squares. I see perfect square here. I see perfect square here. I think I can break that down further. Do it, playa. Okay, I'll do that, sir. So here we go. I break this down to be x plus 2 times x minus 2. Because when I have these guys, these square roots, hopefully you're familiar with difference of squares. If you're not, you might want to check out a video on difference of squares or special products of squaring polynomials. Okay? So this guy would break apart into x and positive 2 and negative 2 multiplying together to make this negative 4. I'm going to make that a little clearer. All right? And then my final one here is 2x plus 3. So the factored form, the final factored form of this original polynomial is x plus 2 times x minus 2 times 2x plus 3. I hope you had as much fun as I had, and I hope you have a wonderful day. Peace.